A conservation officer needs to know the width of a river. So we're trying to find this width right here. In order to set the instruments correctly for a study of pollutants in the river, from point A to point B, the conservation officer walks 110 feet downstream and sights point B. And you notice it creates a right triangle. So we have 30 degrees as theta. We don't know the hypotenuse, and we don't know the length of the river. So we have to use one of the trig functions. So we know that we have sine of theta, which is opposite over hypotenuse. Or we can use cosine of theta, which is adjacent over your hypotenuse. Or tangent of theta, which is opposite over adjacent. In this case, we're going to have to use tangent of theta, since we don't know the opposite, the width of the river, and we do know the distance or the adjacent side of this triangle. So you're going to write tangent of theta is equal to the width of the river, in this case it's y, over the adjacent side, which is 110 feet. We're going to go ahead and find tangent of 30. I recommend to wait until the end to do that. Y over 110 feet. You notice we have two fractions. So we're going to go ahead and multiply, cross multiply. Y times 1 is y. And we have 110 times the tangent of 30 degrees. Now, when you find the tangent of 30 degrees, make sure that your mode is in degrees, okay? When I evaluate this, I get y equals 63.50. So approximately 64 feet. So the width of the river is 64 feet.